Hi everybody and welcome to another Bowtie Teacher video. Today I'm going to take you through a walkthrough of the January 2020 1H paper for Edexcel IGCSE Maths. So let's take a look. The first question, we have 2 points A and B and we have to work out the midpoint. So we can simply take the average of the two x coordinates, so 5 plus 13 over 2, and then the average of the two y coordinates, so negative 4 plus 1 over 2. That will give us 5 plus 13 over 2 is 9, and minus 4 plus 1 over 2 is negative 3 over 2, or negative 1.5. We have an equation, y equals mx plus c. We should rearrange this too, so minus 3x plus 2. So there the gradient will be negative 3, as that's the number in front of the x. And we want to know if it goes through this point 100 minus 302. If that's the case, then the y-coordinate minus 302 will be equal to 2 minus 3 lots of the x-coordinate. So on the left-hand side, we have minus 302, and on the right-hand side, we have 2 minus 300, which does not equal negative 302. So is it on a line? No, it's not, because they're not, the coordinates match there. Lowest common multiple of 28 and 105. So 28 would be 2 and 14, 2 and 7. And for 105, we have 3 and 35, 5 and 7. So the HCF would be 7, and the LCM would be the HCF multiplied by whatever's left over. So we've got a 2, a 2, a 3, and a 5, like that. So when we multiply those together, we have 28 times 15, and that will be equal to 140 plus 280 is 420. Question 3 is a compound shape, and it says the area of this is 129. Work out the value of x. So if we split this into two chunks here, we just need to work out that value there, which we can see from the left-hand side is 9 minus 6, so 3 centimeters. So this is 3x. The area of the larger rectangle will be 12 times 9. So that equals 108 centimeters squared there. So we know that 129 total is 108 plus the 3x. So we can rearrange this to get 21. So x equals 7 centimeters. Question 4, grouped frequency. The modal class will be the one with the biggest frequency, which in this case is that one. So we have 3 less than w less than or equal to 4. And then we have to estimate the mean. So we need the midpoint, and that will be 2.5, etc. And then we're going to multiply those by the frequency. So MP is going to be our x, and then we do the f times x column here. So 12 times 2.5 is 30. 16 times 3.5, 56. Then 9 times 4.5 is 40.5. Then we have 11 and 6.5. So we're going to total those up to get 144. And then we're going to divide that by the total frequency, which is 40. So the final answer will be 144 over 40. And that equals 3.6. One of the babies is chosen at random. Find the probability that this baby has a weight of more than 5 kgs. So more than 5 would be these two here. So 2 plus 1, that's going to be 3. And out of the 40 in total. Question 5, 120 children go on holiday. The number of girls to boys is 3 to 5. So we can split the 120 into 8 pieces. That's 15, and then multiply that by each of these to get 45 to 75. On Sunday, all of the children either go sailing or go climbing. 16/25 of the boys go climbing. So 16/25 of the boys is equal to 48. So that leaves 27 for the sailing. So 27 of the boys go sailing, and twice as many girls go sailing as climbing. So if we say 2x are sailing and x are climbing, so we can divide 45 by 3 to give you 15. So 30 to 15. Okay, so 30 are the sailing out of the girls and 27 for the boys. So that's a 57 total per sailing. 7.8 times 10 to the negative 4 as an ordinary number. So we have the 7.8 and we're going to move the decimal place 1, 2, 3, 4 like that. And then work this out as an answer. So 5.6 times 10 to the 4 plus 7 times 10 to the 3 divided by 2.8 times 10 to the negative 3. So 1, 2, 3, like that. Give your answer in standard form. So that is 2, 2, 5, and then 1, 2, 3, 4, 5 zeros. If you want to use the standard form mode on your calculator, then take a look at my calculator video. Otherwise, we have the decimal point there, and we've gone 1, 2, 3, 4, 5, 6, 7. 2.25 times 10 to the 7, like that. Expand and simplify. M squared plus 5m minus 8m minus 40 gives us m squared minus 3m minus 40. Fully factorize this. We've got 5y as a common factor, so 1 plus 4y there. Anything to the power of 0 is 1. And then we have an algebraic fraction, so we can multiply both sides by 2 to give you 6 brackets 2x minus 5 is equal to 9 minus x. Multiply this out to give 12x minus 30 equals 9 minus x. 13x equals 39, so x equals 3. On the grid, enlarge the shaded shape with scale factor of a half and center 1, 2. So we'll put the center there. You're going to connect all of the vertices with this point here. And then we just have to count the distance of each vertex from the center of enlargement. So let's take the bottom right one here. If we go from the center, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 squares. So 1, 2, 3, 4, 5, 6, 7 puts that there. That will allow us to work out the rest of these like that, making sure that we connect these up with a ruler. Question 9, we have a length PQ that we have to find, so let's call that x. And in this question, we have the adjacent and the hypotenuse, so we're going to use cosine. 63 is equal to a, which is 24.3, over the hypotenuse. So x is 24.3 over cos 63. Work that out on our calculators, and that gives us x equals 53.5 centimeters to 3 SF. Question 10 is an inequality question, and it wants us to write down the 3 that we have here. So if we take the diagonal line at the bottom, which is this one here, then everything is above that line. So we would have y is greater than or equal to a third x minus 2. Everything's to the right of this line here, which is x equals negative 1. So x is greater than or equal to negative 1. And then we just have to work out the equation of this line here, which has a gradient of negative 1 and goes through 4. So that equation will be y equals 4 minus x. So y is less than or equal to 4 minus x, like that. Question 11 is a compound interest question. So we have $6,000, which we're investing at 1 plus 1.5 over 100. And we raise that to the power of the number of years. So when we do that on the calculator, we get 6181.35. We take that amount and we're going to invest it, and we don't know the percentage, but it's going to be 1 plus the percentage. So let's say 1 plus x over 100. And that would give us 631116. So we can rearrange this to give you 1 plus x over 100 is equal to those two divided by each other. So 6311.16 divided by that gives us 1.0210 dot dot dot. So we can now subtract 1 from both sides, 0.0210, and then times by 100 to give you your percentage. So subtract 1, and then times 100, and you get 2.1% to 1 decimal place. Question 12, we're looking at the interquartile range, and there's 80 men and women that took part. So for the upper quartile, we want the 75th percentile, which is at 60. So we take that along and take that down, and we're going to go to the 25th percentile, which will be at 20, and we can read both of these off here. So we have, for the lower quartile, we have 38, and then for the upper quartile, we're going down at 56. To work out the interquartile range, we're going to subtract those two. So 56 take away 38 is going to give us 18 minutes. Part B, 60% took 50 minutes or less for the race. No women took 50 minutes or less. Work out an estimate for the number of men who took part. So 60% of the men took 50 minutes or less. So we can read off our 50 minutes here. So we would draw our line up at 50 and come across. And that is equal to 42. So 42 people represents 60% of the males. So we can divide by 0.6 to get 100%, or you can divide by 6 and times by 10. 42 divided by 0.6 gives us 70. So that's an estimate for the number of men who took part in the race. Question 13 is a pressure question. We have a pressure of 0.14 and a force of 56 newtons, and then we have an area of W squared. So W squared will be 56 divided by 0.14. And to work out the volume of the cube, we're going to have to do the square root of W squared, and then we're going to cube that. Okay, so 56 divided by 0.14, we're going to square root that and then cube it. That's the same as raising it to the power of 3 over 2. So we do 400 to the power of 3 over 2, and that gives us W cubed is equal to 8,000 centimeters cubed. Question 14, we have a parallelogram, and we have to work out the area, but we need to have the vertical height of this to actually work that out. So we're going to have a triangle here where we have F and E. We're going to make that right angled, and the angle in there, if we take off 90, will be 16 degrees. 9.3 there. So we have the adjacent, and we are given the hypotenuse. So we're going to do cos of 16 is equal to A over 9.3. A is going to be equal to 9.3 cos 16. Once we have that, we can multiply that by 14.7 to give you the area. So 14.7 times 9.3 cos 16 gives you 131 centimeters squared to 3SF. For part B, to work out the diagonal, we have e.g. we have 14.7 here and 9.3 and an angle of 106. So if we're trying to work out the diagonal here, let's call that A, then A squared is equal to 9.3 squared plus 14.7 squared minus 2 lots of 9.3, 14.7, and cos 106. So that's the cosine rule. So we plug that all into the calculator, and that gives us 377.9. So when we square root that, we get 19.4 to 3SF. Question 15, we have a volume of a cuboid, and we have to find the volume. So we're going to multiply out all of these brackets. So we're going to do 2x plus 5 multiplied by x plus 1, and that gives us 2x squared plus 2x plus 5x plus 5. And then we're going to multiply that by 3 minus x. So 6x squared plus 21x plus 15. And then we're going to do minus 2x cubed minus 7x squared minus 5x. If we collect all of that together, we have negative 2x cubed Then we have 6x squared minus 7x squared is minus x squared. 21x minus 15x is 16x. And then we have a plus 15 there for the volume. So we can just rearrange that to get the same numbers as the question asks us to do. Then we have to do some differentiation. So the volume was 15 plus 6x minus x squared minus 2x cubed. So when we differentiate that dv by dx, we get 6 minus 2x minus 6x squared. And it wants us to find the maximum value for this. So we're going to need to put that equal to 0. And we can rearrange this to get 3x squared plus x minus 3 equals 0. Now, as the question is asking us for 3 significant figures, this probably won't factorize. So let's complete the square on this. Divide everything by 3, and we have x squared plus x over 3 minus 1 equals 0. So we're going to do x plus 1 over 6 squared minus 1 over 6 squared minus 1 equals 0. So x is equal to negative 1 over 6 plus or minus square root of that minus 1. That's going to be 37 over 36, which will give us that. So our 2x values are minus 1 plus or minus square root of 37 all over 6. There are two turning points of this horrible cubic, and we have to show which one is a maximum. So we'll differentiate a second time d2v by dx squared, and that will give us minus 2 minus 12x. So when we substitute in the first x value, minus 1 plus root 37 over 6, when x equals minus 1 plus root 37 all over 6, then the second differential is going to be negative. And when we put in x equals minus 1 minus root 37 over 6, then the second differential will be positive. When you have a negative value for the second differential, this is the maximum and this is the minimum. So in this case, we're looking for the maximum. So it's going to be minus 1 plus root 37 over 6. So that value to 3 significant figures is 0.847. Question 16, we're looking at the upper bound of p. So when we want the upper bound of p, we want the largest numerator that we can possibly get. So 2 lots of the upper value of a minus the smallest value of c. And we want the smallest possible denominator so that we can divide by a small number there. So we need 2 lots of the upper bound of a. 58.4 correct to 3 significant figures. We're going to go up to 58.45. And we're going to subtract the smallest value of c to 2 significant figures is going to be 19.5. And we're going to divide that by the smallest d to 3 significant figures is 3.55. So whenever you're looking at the bounds, you go to your accuracy, so 3 significant figures, so you would go to the next decimal place in this case. For the second one, 2 significant figures, that's the units column, so we go to the tenths column and go up and down half the accuracy, and the same for the part for D. So when we put this into the calculator, we get 27.44 to 2 decimal places. Question 17, we're multiplying out some surds. So 6 plus 2 root 12 multiplies 6 plus 2 root 12. That would give us 36 plus 12 root 12 plus another 12 root 12 plus 2 times 2 times root 12 squared. So that will give us 36 plus 24 root 12, and then we have 2 times 2 times 12 is 48. That will give us 84 plus 24 root 12, and we can take the 12 out as a factor, and we get 7 plus 2 root 12. We want this answer as root 3, so let's simplify this last one. 7 plus 2 lots of root 4 times 3, and that will give us 12 lots of 7 plus 4 root 3. Part B, we've got a negative and fractional indices. So let's flip it upside down first to get t to the 15 over 27a to the 12, all to the power of 2/3. So we flipped it upside down to get rid of the negative. And then we're going to do t to the 15 to the 2/3 divided by 27 to the 2/3 multiplied by a to the 12 to the 2/3. Okay, so 15 times 2/3 is going to be 10, t to the 10, over 27 to the 2/3 is going to be cube root of that squared is 9, and 12 times 2/3 is going to be 8, so a to the 8, like that. Question 18, there are 16 sweets in a bowl. They take a random sweet, work out the probability that the 5 lemon sweets are still in the bowl. So this is the probability that you're not getting lemon each time. So not lemon, and not lemon, like that. So 4 plus 7, that's 11 sweets that aren't lemon out of the 16 to start with. Then we're going to have another lemon, but there's going to be 15, and another not lemon out of 14. Okay, so we're going to try and cancel some of these. And we get 33, and 8 times 14, which is 112. Here we have some 3D Pythagoras and trigonometry. So we're trying to find the line between AH and the plane EFGH. So A to H is going to come down here. We need to take this diagonal across and make a new right-angled triangle like this and find theta. So FH is going to be 9 squared plus 5 squared and square root that. So a square root of 81 plus 25 is 106. And then we have the height of this, which is going to be 6 centimeters. So we can draw a new triangle here where we have theta, root 106, and 6 is the opposite there. So we're going to use tan theta is equal to 6 over root 106. Theta is shift tan of that. So we're going to do shift tan of 6 over root 106. And that's 30.2 degrees. Question 20, we have completed the square version of a quadratic here. So when we have this form, then our coordinates of the x value for the turning point is going to be the opposite of -1, which is +1. And this part here, negative a, is going to be the y coordinate of the turning point. It tells us that a is greater than 4, so this is going to be down here, like that. So when we put this on this axis here, if we make that x coordinate 1, and this is going to be a, then that is the coordinate there, 1, negative a is going to be the coordinate of the turning point. So our curve is going to go down through the turning point and then back up again in a kind of symmetrical fashion there. We need to have, in terms of a, the coordinates of any points of intersection with the coordinate axes. So our original equation was y equals 4 brackets x minus 1 squared minus a. So we need to now find the y-intercept when x equals 0. So y is equal to 4 lots of x is 0 minus 1 squared minus a. So that's going to be 4 minus a here. So that is the coordinate 0, 4 minus a. And then we solve this equation by putting y equals 0. That will give us the 2x coordinates. So we're going to do 0 for y is equal to 4 x minus 1 squared minus a. We're going to add a to both sides and divide by 4. That will give us x minus 1 squared. So when we take the square root, we get plus minus root a over 2 is equal to x minus 1. So I'm going to add 1 to both sides and I get 1 plus or minus root a over 2 for my two x values. So this one here will be 1 plus root a over 2. And this one over here will be 1 minus root a over 2. Question 21, we have a functions question. So we have to do g of x, which is x plus 3. And we have to put that into f, which is going to be replacing any x with an x plus 3. So we have x plus 3 squared minus 2 lots of x plus 3. This will give us x squared plus 6x plus 9 minus 2x minus 6, which will simplify to x squared plus 4x plus 3. Now we need to do, this is h of x, and we now need to do the inverse, but we can't do the inverse of a quadratic. So we're going to just make sure we complete the square on this. So we're going to do x plus 2 squared minus 2 squared plus 3. And that gives us x plus 2 squared minus 1. So this is our hx. So we can do the inverse of this. So inverse, let that equal to y. So the inverse, we're going to switch the x and the y's. Y plus 2 squared minus 1. And try and make y the subject. So x plus 1, we square root that. That will give us y plus 2. And we can subtract 2 from both sides. So minus 2 plus or minus the square root of x plus 1 is equal to y. So this is now our inverse function like this. Okay, we have to be a bit careful with this plus minus because we've got a restriction on the domain here. So the domain of this one is going to be x is greater than or equal to negative 2. So when we do the range, if I just go in a bit more detail here, the range of h of x, which when we completed the square here, tells us that our curve, if we sketch it quickly, is going to do something like that. And the turning point is going to be at negative 2 and negative 1. So for all values of x, this would be greater than or equal to negative 1. We're restricting the range from negative 2. So all of the left side of the graph has gone, and the range is still h of x is greater than or equal to negative 1. Now when we do the inverse, so for h1 of x, the domain is going to be x is greater than or equal to negative 1. So that's the reverse of the normal function. And the range is going to be h1 of x has to be greater than or equal to negative 2. What that means is if the range can only be greater than or equal to negative 2, we can't do minus 2 minus this thing, because that would result in us breaking the rules of the range. So we have to eliminate the plus minus bit there, and we just stick with our plus for our inverse function. Okay, a bit more detail than perhaps you need there, but that's why we don't have the minus sign on the bottom there. The final question is some coordinate geometry. So let's just do a quick sketch of what's going on here. We have h is at minus 4, 1, and we have a gradient of 2, so it's going to be quite a steep line. Let's just sort of put that through there like that. It joins up to a point M and has a gradient of 2, and M is the midpoint of J, which is J, 15, but J is less than 0, so it's negative, so it's going to be sort of up here. That's J, and it's midway between that and K, which is at 6, K. So 6, K, it might be sort of round about here, because K could be negative, we don't know. That's k. So these come down here at right angles to each other, because if we imagine we have an isosceles triangle like that, H, M, J, and K, like that, this is coming down at right angles. So we're trying to use the coordinate geometry to work out what's going on. If we have a look at HM, it has a gradient of 2, then we can try to work out where that is in space, because it has a gradient of 2. So let's say it's y equals mx plus c. M is the midpoint of j and k, so we're going to take j plus 6 over 2 for the x coordinate, and 15 plus k over 2 is the y coordinate for m. So we can substitute these into this 15 plus k over 2 is equal to the gradient, which is 2, and we have j plus 6 over 2 plus c. We also know that this has a gradient of 2, so if we start off at negative 4 and we go across 4 to here, that means we must have gone up 8. So this value here has gone up from 1 on the y, negative 4, 1. It's gone up another 8, so that's actually at 9, that point there. So we know that c is 9. So if we multiply everything by 2, we have 15 plus k is equal to 4 lots of j plus 6 over 2 plus 18, and then this will cancel. So we're starting to build up a simultaneous equation situation with these. K equals 2j plus 15. So that's our first simultaneous equation. The second one's going to involve a quadratic, because we're looking at the length of jk being root 80. So to work out the root 80 squared, we're going to use Pythagoras. Root 80 squared is equal to the difference in x coordinates plus the difference in y coordinates. The difference in y squared. So we have 80 is equal to j squared minus 12j plus 36. And we're going to substitute for k in here. So plus 15 minus the k from this equation, 2j plus 15 squared. So we start to collect this together. We've got 80 equals j squared minus 12j plus 36 plus 15 minus 15, and then we've got negative 2j all squared is going to give us plus 4j squared. 5j squared minus 12j minus 44 is equal to 0. And then we can factorize this to give j plus 2 and 5j minus 22. Because j is negative from earlier in the question, then j must be equal to negative 2. So we can ignore this one here, which is the positive value, and our k value is equal to 2j plus 15. So 2 times negative 2 plus 15 is 11. Okay, so a very in-depth question there to finish off with. I hope that was useful to you, and that you can use this to help you with your revision. If you have any questions at all, please let me know in the comments, or you can email me at mrwakeling@bowtieteacher.com. Good luck in the summer.